Okay, this is Dr. Williamson. I'm going to go over this worksheet for you guys so you see how it works. Okay, this is 62,250,000. To turn it into scientific notation, I need to move the decimal point 1, 2, 3, 4, 5, 6. What is it? 7 decimal places to the right. So that will be, let me change the 6.225 times 10 to the 7. This one, I need to move the decimal point 1, 2 decimal places to the left. So it'll be 2.2 times 10 to the minus 2. This one, I need to move the decimal point 1, 2, 3, 4, 5, 6 decimal points to the left. So it'll be 8.6 times 10. What did I say? 6 decimal places to the 10 to the minus 6. This one, I have to move the decimal point 1, 2 places to the left, everything you own in a box to the left. 8.31 times 10 to the minus 2. This I have to go 1, 2, 3, 4 to be 7.06 times 10 to the minus 4. Turn it into scientific notation. This, I have an invisible understood decimal point here. And I have to go 3 decimal places to the right. So it'd be 1.006. Make that decimal point a little clearer. Okay. Times 10 to the 3. Okay. That's how you do those. Let's kind of clear those out and scroll down to the next problems. Fill in the following, go back and express each answer in scientific notation. All right. So for this one, I need to make this number 1, 2 decimal places smaller, 4.27. I need to make this 2 decimal places bigger, times 10. 2 decimal places bigger than -5 will be -3, because on a number line, this is 0. If this is the -5 place, the -3 is 1, 2 decimal places larger, meaning, more positive. I need to make this number here 1, 2, 3, 4 places larger, 8.16 times 10. And if I made this 4 decimal places larger, I need to make this 4 decimal places smaller. So smaller would be in the more negative direction. That'll be 10 to the negative, or 10 to the -7. Right? If I start at -3 and I go 4 more places, that'll be -7. 6.32 times 10. I made this number 1 power of 10 smaller, so I need to make this 1 power of 10 bigger. That'll be 10 to the 6th. I need to make this number 1, 2, 3 powers of 10 smaller, 9.765 times 10. If I made this 3 powers of 10 smaller, I need to make this 3 powers of 10 bigger. 3 powers of 10 bigger means more positive on the number line. So that'll be times 10 to the negative 3, right? Because negative 6 is way over here. And I got to go 1, 2, 3 powers of 10 bigger. 2.98. Need to make it 2.98. That's supposed to be a 9. That's 1 power of 10 smaller. So I need to make this 1 power of 10 bigger. 10 to the 5. This you just leave alone. It is in scientific notation. Times 10 to 10. Don't do anything to it. This I need to make 2 powers of 10 smaller. 6.23 times 10. If I make this 2 powers of 10 smaller, I need to make this 2 powers of 10 bigger. That'll be 23. Right? 2 powers of 10 bigger. I need to make this 2 powers of 10 bigger. 6.63 times 10. And if I made this 2 powers of 10 bigger, I need to make this 2 powers of 10 smaller. That means more negative. So it's 10 to the negative 27. Okay, and that's how you do those. Here, when you multiply, you add exponents. 10 to the 2 and 10 to the 3 is 10 to the 2 plus 3. That's going to be 10 to the 5. 10 to the 7 times 10 to the negative 3. That's going to be 10 to the 7 plus negative 3, or 7 minus 3. That's going to be 10 to the 4. Here, this is going to be the same as 2 times 3 and 10 to the 5 times 10 to the negative 2. You could break it up like that, like I taught you guys in lecture. So that'll be 6 times, and that'll be 5 minus 2, 10 to the 3. Let me erase this stuff, make some space. Here I got 5 times 3 is 15 times, I got 10 to the 2, or 10 to the minus 2, times 10 to the minus 4. That's going to be 10 to the minus 6. So that's going to be 15 times 10 to the minus 6. But that's not in scientific notation, because it said scientific notation. So I need to make this 1 power of 10 smaller. That'll be 1.5. That means I need to make this 1 power of 10 bigger. And when I do that, I'm going to end up with 1.5 times 10 to the negative 5. 4 times 2 is 8. 10 to the 4 and 10 to the negative 6. That'll be 4 minus 6, be 10 to the negative 2. Okay. This is 10 to the 2 minus 5. That'll be 10 to the negative 3. Okay. 10 to the negative 3. 8 divided by 2 is 4. Right? I can do it like this. I can do that piece. Now I can do this piece. Whoops. Do this piece. 8 divided by 2 is 4. 10 to the 2 divided by 10 to the negative 6. That's going to be 10 to the 2 minus the negative 6. Minus a negative is positive. So that's going to be 4 times 10. 2 plus 6 will be 8. Okay. And then here I have, I can break this up into 2 pieces. I can do this piece and then this piece. 5.6. 5.6 divided by 1.6 will give me 3.5. So I've got 3.5 times, and here I have 10 to the negative 2 minus that positive 4. That'll be 10 to the negative 6. Okay, it's supposed to be a negative 6, guys. That's kind of a little on the sloppy side. So let me redo that. There we go. Okay. And then one last one. Let me show you how to do this one. This 7 is the same thing as 7 times 10 to the 0. Right? 10 to the 0 is 1. So it's 7 times 1. It's like, okay. Divided by 10 to the minus 2. That's kind of how you can look at it. So I've got 7 times, then I've got 10 to the 0, kind of like a little gimmick there, divided by 10 to the minus 2. So I'll end up with 10 to the 0 minus a negative 2. And that'll be a positive 2. And so when I'm done, I end up with, let me erase this stuff. I end up with here 7 times 10 to the positive 2, which is, if we write it in regular numbers, is just 700. Okay. So I hope that helps. And that's the answer key for this if you take the time to watch the video. All right, then.